so this is our first lesson in scientific notation. And a scientific notation is basically, here's your definition, it's a number that's written in a special way. It's written as a product of two factors. Remember what product means. Product means to multiply. So you can have a multiplication sign in there. And it's of two factors or two numbers. The first number is a number in between 1 and 10. It can equal 1, but it can't equal 10. We'll talk about that. The second number is the power of 10. You've seen this before. It's basically the product timesing of two numbers. One number is a product of 10, it's a power of 10, and the other one is somewhere between 1 and 10. Okay, let's go over the powers of 10 real quick. 10 to the first power is 10. 10 to the second power is like 10 times 10, which is 100. 10 to the third power is 1,000. So you get the idea there's a pattern here that any exponent, if you say 10 to the 6, is going to have, well, if 1 to the first power has 1 0, second power it has 2 zeros, third power it has 3 zeros, to the sixth power it's going to have 6 zeros, which would be 1 million. All right, then with the negative exponents, think about what the negative exponent means. It means 1 over 10. 10 to the negative 1 means 1/10. So it's going to be 0.1, which means it has one decimal place. All right, 10 to the negative 2 is 1 over 10 squared, which is 1/100th, which is 2 decimal places. 10 to the negative 3 is 1 over 1,000, which is 0.001. It's going to be a 1 with the 3 decimal places. So again, we could say 10 to say the negative 5. It's going to be 1 over 10 to the 5th. But even more importantly, the way you want to write it, think about it, is a decimal, and it's going to have 5 decimal places. So that would mean 4 zeros, and then the 1 is another decimal place. So it has 5 decimal places. Okay, let's just talk about some examples. The mass of Jupiter really is 3.7 times 10 to the 27th. So that's an example of scientific notation. 3.7 is somewhere between 1 and 10 is raised to a power. Here we have the distance to the sun that the Earth is. It's 9.3 times 10 to the 7th. Again, a number between 1 and 10 raised to a power. Now I'm going to give you some numbers, and I want you to see if these are written in scientific notation. Is 56.29 times 10 to the negative 2. Is that a scientific notation? Is that a number in scientific notation? Well, is this a power of 10? That's checked. It's a product. That's good. But is this a number between 1 and 10? So no, it is not. Okay? Is this a number in scientific notation? Got my power of 10, check. But I don't have, is this a number between 1 and 10? It's a number between 0 and 10, but not 1 and 10. So it's no, it is not. Is this a number in scientific notation? Again, we have our power of 10, but that 520 is not anywhere in between 1 and 10, so it's not. Okay? If I was to even, supposing I put a decimal there to make it a number between 1 and 10, but supposing I put a plus sign, would that be scientific notation? No, because again, it's not, it has to be a product. Okay? Is 0.04 times 10 to the negative 5th? Nope, why not? Because that's not between 1 and 10. Is this one? Is 3.42 times 10 to the 7th? Yes, it is, because that's the power of 10, and that's 3 is in between 1 and 10. Is 61.1 times 10 to the 6th? Nope, because again, we have that power of 10, but that's not between 1 and 10. So the answer there is no. Okay, so that gives you a little bit of a introduction. All right, now what we have to do, we have to learn how to go from a number, what we call, to write a given number in scientific notation. Okay, so we got to, given a regular number, how are we going to make that into scientific notation? And then we're going to take how to give a number that is given in scientific notation, how to put that back to a regular number, which we call standard form. Okay, so we'll do this one first, getting it into scientific notation first. All right, well, first of all, you want to move the decimal to make it a number between 1 and 10, because obviously that's an important part. So I want to make this, I got to move the decimal. Well, if a number doesn't have a decimal, remember the decimal's at the end, okay, which is where we start. Then you want to count the number of places you needed to move the decimal. All right, so you have to go 1, 2, 3, 4, 5, 6. Is that between 1 and 10 yet? Nope. And then 7. So you have to move it 7 places. Now, and you get 5.69 because that's where the decimal landed, and that is a number between 1 and 10. Now, if the given number is large, is this number pretty big? Yep, pretty big number. Then that's going to be a positive. The exponent's going to be positive. If the given number is really small, which we'll do a couple like number 4 and 2 are small numbers, they're decimal numbers, that exponent will be negative. You can memorize, if I go to the right, then it's positive, go to the left, however you want to. To me, it just makes more sense if I just think about it logically every time. Okay, this one, is this a number between 1 and 10? No. So I've got to move the decimal 1, 2, 3. That's a number between 1 and 10. So I rewrite it 9.85. I remember I had to move it 3 places, and it's a small number, so it's going to be 10 to the negative 3. And that's the number in scientific notation. Okay, this one, starting here, I've got 1, 2, 3. It's not a number between 1 and 10. 4, nope. 5, nope. 10, 1, 2, 3, 4, 5, 6. It's still not a number between 1 and 10. And then 7. There it is. So now I write down 4.6205. Okay, I got to write all those down. Now sometimes you'll be told to round it to the nearest 10th place, whatever, and you can do that. But right now we're just writing them down. Times 10. Okay, to what power? What was that? That was 3, 6, 7. And it was a big number, so it's going to be a positive 7. Okay, this number is going to be, let's see, I got to move it 1, 2, 3, 4, 5, 6, 7, 8. Is that a number between 1 and 10.9? No. So I got to move it 9 places. So it's 9.0, you could say, or just plain 9, times 10. Was that 9 places? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it's 10 to the 9th or 10 to the negative 9th? 10 to the negative 9th, because that was really, really small. So that would be, or you could just say 9 times 10 to the negative 9th. Okay? All right, now we're going to make the number, rewrite it from scientific notation to what we call standard form. Okay, this time you move the decimal the number of places of the exponent. I know it doesn't make total sense, but let's do some examples. Okay, so here's my decimal here. I've got to move it 6 places. Well, I've got to decide if I move it to make it a big number or to make it a small number. Well, if the exponent is positive exponent, you move it so the number is bigger, because that's a big number. 10 to the 6 is a big number. So we go ahead and move it 1, 2, 3, 4, 5, 6. You know, we fill in with zeros as we need to, and then I put the commas in, and that's my number. Okay, if the negative exponent, you move it so that the number is smaller. So for our next example, we have 2. Well, the decimal in 2 is, again, of course, behind it. So I'm going to move it 11 places to make it small. That's going to be really small. We can do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, you can put zeros in all those, or I can say, well, I need 11 places, but 1 is already used up by a 2, so how many zeros do I need? I really need 10 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, and then my 2. And that'll be 11 places. Okay? It's not 11 zeros. Some of you learned, okay, 6, that means I add 6 zeros. No, it means 6 decimal places. You could say 11, oh, put on 11 zeros. No, it's 11 decimal places, so be careful about that. 8.3 to the negative 2. Okay, I start out 8.3. I got to move it so it's a smaller number. 1, 2. So it's simply just going to be 0.083. I don't add on times 10 or whatever. No, because that's the standard form from the scientific notation. It already is in scientific notation. I got to write it without the power of 10 there. Okay, next one. 5.07 times 10 to the 4th. That means 1, 2, 3, 4. So I have to put on how many zeros? Just 2 more, because I already used up 2 decimal places, 2 places with the 2 numbers there. And that'd be 50,700. Last one. Same number, but this time I got to move it 4 places to make it a small number. 1, 2, 3, 4. So this time I have to put on 1, 2, 3 zeros, and then a 507. Okay, no commas in that one, obviously. Okay? All right, now, next one we're going to do is comparing them from least to greatest. Okay, and that's a little tricky. You have a couple steps here to kind of help you do it right. First step is to write each number in scientific notation. We're comparing numbers that are sort of written, I put it in quotes, scientific notation, because these aren't really scientific notation, but they're written in some sort of a product of 2 numbers, except for that one. Anyway, so you'll, first of all, write them all in scientific notation, then order them by the powers of 10, and then order the actual number. It looks harder than it really is. So here's the tricky part, though. To make this into scientific notation, I've got to move the decimal 2 places to make it bigger. If I make it bigger here, I've got to compensate by making the exponent smaller. So in other words, I moved it 2 places here, so I've got to decrease the exponent by 2 here. So it becomes 5.2 times 10 to the 5th. Okay, the next one. This was fine. This is already in scientific notation. I got one freebie there. This one is not scientific notation because it's not between 1 and 10. So this time I went from 53 to 5. In other words, I made the number smaller. So if I made the number smaller, I've got to compensate by making this exponent larger. Remember, this was 1, so to make it 1 more larger, because I only moved it 1 place, I make it 10 squared. And that way they'll be equal. Okay? 5.34 in scientific notation, I have to move it 2 places over, and because it was a big number to start with and I made it smaller, I make this 10 to the 10 squared. I moved it over 2 places. Then you look at first you don't look at the original number, the first number. You want to look at the power of 10, because it doesn't matter what this is going to be 99999, but if it's 10 to the negative 15th, that's a tiny number. So you want to look at first at the powers of 10. So my smallest powers of 10 are these two right here. And then once I look at those two, I look at, okay, which decimal number is bigger or smaller first? That one's smaller. So that's the smallest one. That's the least. Then this one's the next least. Okay? Then I have these two. Well, these both have 10 to the 5th. But remember now, this is 5.2, but it's really 5.20 because you have to have the same decimal places as this one. This has 2, and that has to have 2. So now which one's smaller? This one's smaller. So it's 5.12 times 10 to the 5th, and 5.2 times 10 to the 5th is the largest one. Okay? All right, we'll do one more of those because those are kind of tricky. So we'll do one more of those and be able to hopefully move these guys so they don't fall over. Okay. So, one more. First step is to make them all into scientific notation. So again, let's practice this. Here we have to make this into a smaller number, okay? Because that's smaller, I've got to make this bigger, which means I have to add 1 because I moved it 1 place. So remember, negative 5 plus 1 is negative 4. Okay, this one is 6.63, so I made it smaller. So that means I have to make this bigger. So 4 plus 1 is 5. So that's why that's 10 to the 5th. Here, this was small. I made it bigger. So because I made this bigger by 2 decimal places, I have to subtract 3 minus 2 and make that 1 to make them equal to each other. This is 61. Again, I made it smaller, so I've got to make this bigger. And I only moved it over 1 place. So negative 2 plus 1 is negative 1. Okay, I hope that's clear, and you can rewind that and try that again to make sure you understand that. Now I have to order by powers of 10 first. So which one's the least of the powers of 10? Well, clearly this 10 to the negative 4 is the least. Then clearly this 10 to the negative 1 is the least. This is kind of easy. And then of these two, well, 10 to the first power is the least, and then 10 to the 5th power is the least. And they might have as a multiple choice, they might not have this 10 to the first, but you know that by now, that that's just plain old 10. All right, one more to go. Last slide here. Okay, this one is now not just, we're going to compare how much bigger is 6 times 10 to the 9th compared to 3 times 10 to the 7th. Okay, there's a couple ways to think about this. One way is, in other words, what they're asking you for is 3 times 10 to the 7th times what is going to give me 6 times 10 to the 9th. That might be the best way of thinking about it. Okay, we'll think about it in 2 parts as well, because we're going to do this way. Okay, what times the 3 will give us the 6? Well, that's clear. That's going to be 2. Okay, and what times 10 to the 7th do I get to 10 to the 9th? Well, 7 is how many more than, 9 is how many more than 7? 2, so it'd be 10 squared. Well, so what is this number? 2 times 10 squared is what? Well, 10 squared is 100, so 2 times 100 is 200. So this number is 200 times larger than this one. This number here times 200 will give you that number. And we'll practice more of those in class, but that's it.